So first, the elevator E has a mass ME, and the counterweight at A has a mass MA. If the elevator attains a speed V after rising a distance H, determine the constant force developed in cable B. Neglect the mass of the pulleys and cable. Look, in the exam, you need to understand these problems just to know concepts, okay? But of course, I will not give you a very big problem. So problems will be small, but for the concepts, it's very good to do these problems because you will use same concepts for thinking, okay? So here, what do we have? We have a system of pulleys. We have a block A and an elevator and a motor, okay? So first, whenever I have pulleys, I determine first the number of coordinates I need, okay? So here, how many coordinates I need, do you think?
3.
3, very good. 1 for A, 1 for E, and 1 for the motor, okay? And I will take, because all are displacing in the vertical direction, I will take as reference the horizontal line passing by the center of the fixed pulleys. So this is my reference line, okay? And I will consider coordinate position for A. So this is SA, this is SA, this is SE, and this is SB of the motor. And SB, please pay attention, SB doesn't represent this length, it represents what is going also inside the motor, okay?
مش
So
سؤال.
now, yes.
الإي الإليفيتر إي نحن بنعتبرها ك one particle إيه مش لازم نوصلها على السنتر.
Yeah, one particle. ما أصلا distance to the center is constant, so ما بتفرق شيء. Okay, because the distance here is constant, so it doesn't matter. You can take SE to here. It doesn't matter because the difference between the two is a constant.
Okay.
So now the second step. So first I put the name of my coordinates. I have SA, I have SE here, and I have SB here. Okay, the second step is to search how many chords do I have. I have here 2 chords. This is the first one. Okay, what is the length of this chord? What is the length of this
plus SE.
Very good. It's SE plus SB. So I have SE plus SB equal to constant. And for the second chord, I have SE plus SA. Okay, equals to constant. So also, if I derive these relations, I get that VB plus VE equals 0 and VE plus VA equals 0, and the same for acceleration. Okay, so now I can relate accelerations of this of the motor and elevator and the block A. I can say that acceleration of A is equal to minus the acceleration of the elevator. Okay, and also the acceleration of B is equal to minus the acceleration of elevator. So I deduce that acceleration of A is equal to acceleration of B. Okay, now what do they want me to find? They want me to find the distance of H of displacement of the elevator. Who can tell me how to find it? How to find how much the elevator will rise up?
We get the acceleration and then the distance.
Okay, first, very good. First, I should get the acceleration of the elevator. And since they gave me the final velocity, which relation I can use to calculate the distance h? Do I have time here in this problem? Do I have anything about time?
V squared minus V0 squared.
Okay, because I don't have anything about time, I will use V squared final minus V squared initial equals to 2AE delta
X.
Delta S. Okay? Because here, what is the coordinate for AE? It's SE. So it's 2AE delta SE. Okay? Delta. And you know what? Delta SE will be negative or positive?
Negative.
Negative. It's minus h, okay? So it's equal to 2ae times minus h, because my elevator is rising upward, okay? So now all I have to do, I know the final velocity is 10. I know the initial velocity is 0 because my system starts from rest. I know h. The only unknown is ae. I should calculate ae, okay? Until now, I have related ae to aa and ab. Ae is minus aa and it's minus ab. But it's not enough. I need another equation. What should I do now? I should find another equation for AB or AE.
Sum of forces along y direction.
Very good. I take as free body diagram the free body diagram of the elevator and the free body diagram of the block A. Okay, let us do it.
Miss, we took down as positive, right?
Yes. Jennifer, you took down as positive because these are your coordinates for A, E, and B. Okay. And now, after you get these relations we have talked about from cable 1 and from cable 2, you can relate the accelerations. So AA is equal to AB equals to minus A, and AE is equal to A. Okay. Now, now if we look here, okay, to be able to calculate A, okay, we can do a V square over 2H because V final is given and the H is given. So we can calculate A from this step. And once we can calculate A, we can go back to find the tension. Did they ask for the tension here? Yes, I think they asked for the tension in the cable. Okay, so we consider the free body diagram of blocks A and E. Okay, and now we can apply on these free body diagrams, we can apply sum of y equals ma. Please pay attention. If you choose the upward direction, if you used to choose the upward direction as positive here, you should put now minus MAAA, okay? Because AA is calculated based on downward direction, because we considered SA downward, okay? So, or if I take the positive direction downward, what will be my equation? It will be MAG minus T equals to MA times AA, okay, times acceleration of A, okay? But acceleration of A, let me put here big A, this is MA times acceleration of A, okay? And acceleration of A was proved to be equal to A, okay? We called it A, small a. So it's equal to MA times A, okay? But now if I choose the opposite direction, if I choose to do sum of y in upward direction, what will be my equation? It will be the opposite of this one. It will be T minus MAG equals to minus MAAA. So to minus MAA. Okay, clear? Now, if I consider block E, I can take the downward direction, which I advise you to do, to not put minus. If I take the downward direction, what will be my equation? My equation will be MEG minus F minus T, okay, equals to plus ME times AE, okay?
Miss, A or minus A?
Yes, مظبوط, but AE is minus A, so it will be equal to minus ME minus ME times A, okay? And now, when if I take the upward direction as positive, what will be my equation? It will be the opposite, plus F plus T minus MEG equals to MEA, okay? Clear? Now,
yes.
Okay, now, once I already found the acceleration of A from the previous step, okay, so here I can solve for T and for F. I have two equations with two unknowns. I can solve for the tension in first cable and for the tension in the second cable. Okay?
بس مس ما
Yes.
فينا نستعمل هالسيستم تنلي A بعدين G إنه إذا we subtract them من
No,
A بعدين G
Amanda, you have here, what are your unknowns? You have three unknowns, T, F, and A. إذا ما جبنا A من قبل ما فينا
شي معنا
cannot
A
solve
okay.
for T and F. Okay? Any other question on this problem? Okay, so let us move to another one. Look, I will choose the hard problems for you. This is very simple. Okay, I will just give you the idea here. They gave you here the force, a function of time. Okay, and they want you to find the maximum velocity. So first you get the acceleration from sum of forces equal ma. Because the force is function of time, you will get a function of time. Okay, and since you want to find the maximum velocity, you will derive the expression of velocity first. So we have that the velocity is integral. So you integrate this relation. You do separation of variables. You take dt to the other side because a is function of time, and you integrate this side from 0 to t and this side from 0 to v. You obtain v function of time. Okay. Now the maximum velocity will take place for dv by dt equals to 0. So for a equals to 0. So if we take a equals to 0, you get what should be the time t. Okay. So once you get what should be the time to have a0, you replace back into the expression of velocity, you find the maximum velocity. Okay. So it's a very simple example. You have a question on it, or I move to another or to another example? Okay. Okay, at the instant shown, block A of weight WA is moving down the plane at V0 while being attached to the block B of weight WB. If the coefficient of kinetic friction is mu K, determine the acceleration of A and the distance A will slide before it stops. Neglect the mass of the pulleys and cables. So here we want to find what is the acceleration of A and what is the distance I will slide before stop. Okay, so let us look at our problem here. We have several pulleys and we have two blocks. Okay, so first, can you tell me how many coordinates do we need? How many coordinates do we need here?
3.
3. 1 for block A, okay? And the coordinate for block A will be inclined because A is moving along inclined line. So this is SA. From here to here it's counted. So this is the reference line for A. I can take it passing by the center of the fixed pulley. Okay. So this is SA. Now I need, what is the other coordinate I need?
C.
For C, I can take SC, and I will also take, this is my reference, I will take a horizontal line from here. This is S of C. And what also? Do I need a coordinate for D?
No, it can be the same for C.
Yes, it can be the same for C. And if I put S of D, if I put it, I can get a relation between SC and SD. Why? Because look, the distance from here to here is what? It's a constant distance. So I can say that SC plus this constant plus SD equal to a constant. So SC plus SD is equal to constant. So I can relate SC and SD. So no need to take two coordinates. It's enough to take one coordinate. Okay? And I still need one coordinate for what? For B. I can take it from here, from up, or I can take it from here. This is SB. Okay? Now let us move to another step. The other step is to determine how many chords do I have. How many chords do I have?
2.
2. This is the first one. What is the total length of this cord from here to here? I have from here to here, it's what? It's SD.
SD.
Or constant minus SC. Okay? Plus what? Plus this part. What is the part from here to here?
SD minus SB.
Very good. So it's SD plus SD minus SB. So it's 2 SD minus SB equal to constant. And I can replace SD by constant minus SC. Okay? So this is my first relation. Now I go to the second chord. This is the second chord. What is the length of the second chord? SC plus constant plus SC plus constant plus SA equal to constant. يعني 2SC plus SA equals to constant. Okay? This is my first step. But I have a lot of unknowns, so it's not enough to get these two relations. Okay? I need to move forward. What is the next step to do?
بس سؤال.
نعمل الفري بودي دايجرام.
هو البروبلم شو بدنا ايانا نلاقي؟
البروبلم بده ايانا نلاقي the acceleration of A, okay, and the time. هن عطونا ال initial velocity of A. بدهم ايانا نلاقي the time needed to stop A. Okay? يعني A was moving at 5 feet per second. Suddenly حطينا block B. block B حيمنعه ينزل لتحت. It will decelerate A until reaching a velocity of 0. Okay? نحن بدنا نعرف شو هي acceleration of A اللي حتكون negative أكيد. و at the distance it will move before stopping.
Okay.
Okay? Now, so as the first step, as we said, we put the relations for the chords. Now the second step after, because we got here 3 relations, but how many unknowns do we have? Look, I have 3 relations, but I have unknowns AA, AC, AB, and AD. So I have 4 unknowns, 3 equations. It's not enough. I should find other equations. Other equations can be found from the free body diagrams of my parts of my body. Okay, so I will draw the free body diagram of block A. I will draw the free body diagram of block B. And which free body diagram is important also for which part?
The pulley.
The pulleys. It's very important to draw the free body diagram of this part here. This part is very important. You know why? Because it will relate the tension in this cable to the tension in this cable. Okay? Because once I take this part, what can I say? If I draw the forces, this is cable 1. So here I have T1 and here I have T1. Okay? And here I have, in the second cable, I have T2, T2. And because the mass of the pulley is negligible, what can I say? 2T1 equals to 2T2. So T1 is equal to T2. So I have one tension, the same tension in cable 1 and cable 2. Okay? Now I can move to the free body diagrams of each part. Okay? So as we said, we take the free body diagram of the pulleys, we get that TA is equal to TB. Now if I take the free body diagram of block B, I have the weight of B and the tension of at the cord. So it's plus WB minus TB equals MAB. Okay. Now please pay attention here. In this problem, how is SB upward or downward?
أخذناها upward.
أخذناها upward. لأنه أخذنا SB upward كيف حنطبق نيوتن لو؟
upward.
بالupward. So it's plus TB minus WB equals to plus MBAB. إذا بدنا نعملها بالdownward direction شو بدنا نحط هون؟ minus MBAB. Okay? And now for block A, what do we have? We have block A is moving down. So we have the friction, which will be upward. It's mu K and A. We have the normal reaction. We have the tension TA, and we have the weight. Okay? So now for block A, if we project along direction of motion, what do we have? We have plus TA And here we are applying the positive direction downward because SA is downward. Okay? So this is SA. So it's plus. Now if you want هن حطوها عملوها بالopposite direction بس شو حطوا minus MAAA. Okay? لأنه they applied the Newton law in upward direction اللي هي opposite to SA. شو حطوا للA؟ حطوا minus MAAA. Okay? So minus MAAA will give us a relation بالupward direction. So plus TA minus the projection of the weight. So minus WA sine this angle, which is theta, minus WA sine theta, and plus the friction, plus mu K NA. Okay? Equals to minus MAAA. Now how to find NA? To be able to find NA, we apply which relation? How to find NA, the normal reaction here? What should we
sum along Y.
We sum along Y. Because along Y no motion. Sum of Y equals
sigma Fy is equal to 0.
So plus NA minus WA cosine theta equals 0. This equation will allow to calculate NA. Once we have NA, we replace back here. Okay? So we end up with 7 equations with 7 unknowns. TA, TB, NA, AA, AB, AC, AD. But of course, the solution is simple. Why? Because, for example, TA is equal to TB. So you directly, here you get 1 unknown, T, instead of 2. And NA is given, so you replace it here. So you are, when you take these 2 equations, okay, these 2 equations involve only 2 unknowns, the tension and AA, because AA and AB are related, okay? So you can simplify your analysis by solving step by step. Okay? Questions on this problem? Okay, so let us move to another one.
Miss.
Yes?
Professor,
yes.
Can I ask a question?
Yes, of course. Tell me. Yes, Jennifer. Look, Jennifer, I'm not able to hear you. Can you type your question?
Yeah.
Yes. Yes, in the beginning we considered SA and SP to be able to relate acceleration of A and acceleration of B. What was the problem? Not SA plus SB. Look, I will go back to the figure. We didn't take SA plus SB constant, Jennifer. We said SC plus SD constant. Okay? Look, here. We said that if I consider this is SC and this is SD, the total distance between the two is constant. So I can say that SC plus SD is a constant. Because look, the distance from the floor to from the ceiling to the floor is constant, okay? And this distance is equal to what? Is equal to SC plus a constant plus SD. So because it's a constant, then SC plus SD is equal to constant, okay? Did I answer your question? Okay. Any other question? So let us try to do another problem.
دكتورة
Yes, Munir.
في شيء بهذا التشابتر كنت معلق عليه من فترة بس نسيت. لما حكينا عن البي اكسس بالبي ام بي فريم.
Yes.
في عم شوف شيء انه في شيء اسمه التورشن اللي هو عرفنا بالبي ايكوال تي كروس ان، قلنا تاو ايكوال ماينس دي بي على دي اس دوت ان. شو هي هيدي الكوانتيتي؟
منير ما عم بفهم عليك. فيك تكتبها وتبعت لي اياها واتساب تجاوبك عليها؟
بصور لك هي؟
ايه بليز.
طيب
Okay. So car B has a mass M and is released from rest when it is on the top of cart A, which has a mass of 3M. Determine the tension in cord CD needed to hold the cart from moving while B is sliding down A. Neglect friction. So in this problem, box B is going down on cart A, okay? But we don't want cart A to move. So cart A is at rest and B is moving. They are saying what should be the tension in CD to prevent motion of cart B. So in this problem, we should first draw the free body diagrams of our two parts, which are the block and the cart, okay? First, if we consider the block, what are the forces acting on the block? We have the weight of the block, and we have the normal reaction from the crate A on the block, which is NB, okay? And we know that by principle of action reaction, if the crate is doing on the box an upward reaction NB, then the box will do on the crate an opposite force in the opposite direction of same magnitude NB, okay? So here when I take the crate, I put NB opposing this one, and we have in addition the weight of the crate, the normal reaction with the ground, and the tension T, okay? Now, to be able to get the expression of T, we will apply the conditions of motion we have motion for the block, and we have the cart in equilibrium. Because the cart...
هيدا حليناه بالريسيتيشن.
حليتوه بالريسيتيشن؟ ماني عارفة سوري. اوكي. So ببقى في I skip it؟
ما بعرف حلينه إذا حدا ما بعرف.
أصلاً ما بقى في وقت. يلا حخلصه. بدكم نعمل غير سيشن ولا عندكم صف؟ طب يلا. So here I do sum of forces equal 0 on the cart along x direction. I obtain minus t plus nb sine theta equals to 0.